and start a little bit of presentation, but that will actually do some demonstration like live, real life. But Johnny already actually did some good introduction about the Volvo's use case. And if I could understand correctly, Jens also previously talked about the machine learning process for mainly one model, like the one use case. You have the idea, all the plannings and all the steps up to the production in order to have a model and running in production reliably and like traceable and observable and so on. One model is great, but when you need to do this for hundreds of thousands of times, you could just continue to do the same things, but that opens up actually a lot of human errors, a lot of time. So we started looking into like how we could actually, start automating this process. So manual retraining could become unsustainable, and there could be, if you start doing things more manually or like human-driven, there could be those like snowflakes model deployments, or like you won't be able to really track off who did what, or what kind of data actually went in, or which version of the pipeline of the code that you used in order to build this model. And then, of course, you need to bring the security into the picture. You cannot think these things in the last minutes. So we started thinking about these things, and also like think about how can we make this thing as easy as possible for the people who are actually building these models. So what we've seen is that like having a good onboarding process is really important when you are actually scaling up. So that means is that without getting into all the details, getting into the weeds of the mechanics of all the automations happening in the back, or all the tools and products that are needed in order to take the model production, without getting into all these weeds, you need to give like a simple onboarding process for the data scientists or the ML engineers, so that they can actually focus on the important bits, the quality of the model. And the automation, the more automation you bring, that means that you are fastening the process, you're decreasing the time to value, and also like you are actually decreasing the error possibilities. And when you actually start building automation, you actually bring in the security as early on, so you can actually start catching the problems or like the regressions before you go into before introducing in your production environment. We are talking about the models, the predictive models, so there will be questions regarding the explainability, like why this model actually predict this, or like what type of data that we used when we are actually building this model. So all these kind of things are getting more and more important. So when you invest in automation, when you invest in, when you are scaling up, you need to invest these things, and also the things around the reliability and infra scaling type things as well, quite important. So what we thought, and what we're going to show you actually, and I mentioned that we want to lower the entry barrier for such model onboarding, and like lower the time from idea to production. For us, the important thing is that you start with defining like what is this model about that you want to take into production. Like there is this idea, you just need to define the model and the most important things about that model, like from starting things like the model name, the model architecture, some parameters regarding this model, what type of training pipeline that needs to use in order to retrain this, continuously training this model. And as a data scientist, as the end user, this is the part that you need to provide. But from that point, things can be actually automated. So we can take this information, and with all these ready components, like some automated training pipelines, automated deployments, processes, and we could actually start building and testing the model. And then during the training, we can also do the validation and keep all the tracks of the process, like what type of pipeline that was used during this model building, or which data was used. So the data versioning is also quite important in here. And then the resulting artifacts, we also need to version these resulting artifacts. We need to have this, still have the traceability. of the, we have the pipeline trace, we know which pipeline built this, we know what kind of data used, we need to know the resulting artifacts, and we need to be able to say that this model is now running this test environment, and the next step is the production environment to promote it in an automated way. All these things, it's just the starting point as like someone needs to provide like which model, like what is this model about, what kind of data that needs to be used in order to train such model, in order to build this model. And from that point, also the life cycle of this model, like you need to monitor the model and you need to be able to automatically retrain the model. Whether it is a config change, a parameter change, or a new data, fresh data, or the change in the data. So this is what we are going to show you. So as a data scientist, you are on the left side, you are getting ready to take another model into production, but this time it's not going to be like manual process. What you are going to do is that you are going to interact with a Git repository. So in this Git repository, you'll see some JSON files. That these JSON files, we are actually not sure exactly what type of track part names that we could use for the demo. So we use very high level parts. So sorry about that. It's like engine, exhaust, tire, wheel. So whatever the part demand that you are going to predict, you need to be provide that file. So we came up with this type of a JSON structure, the informations that I mentioned previously, like you provide the model name, what kind of training pipeline you want to use, the runtime like of this model, some parameters, and then as a data scientist, you create that kind of a file. You put this into Git. This makes that this model traceable. All the good things that comes with Git. Basically, when you push something to Git, it stays there in the history. When you write a good commit messages, it easily show like this person wants to onboard this model at this time, so they put this file in it, and the rest actually is going to be an automated process. So this push that you do into a Git repository is going to kick off a pipeline, a continuous training pipeline, and going to actually do all those steps that I mentioned, going to version the data, or like going to pull down a version data and going to start training the model. The model, after the model is built, and version the artifacts, it's going to take these artifacts and into a test environment, and then promote the production environment.
So here are our models. As Cansu said before, they are all defined as JSONs. And let me know if it's too small, by the way. Sometimes screen resolution doesn't quite match. And we define a bunch of things, right? Your question about how exactly we define model comes in here in the pipeline, which we're going to look at in a second. But before that, I just wanted to show, if we have this model and say we want to add a new model, we can simply just throw in a new of these config files. So as Cansu mentioned, we're terrible at car parts. What's another part which we're missing here? Brakes? Brakes, all right.
Yeah.
So let's do like brakes predictor.json. I'm going to use the same data. I'm going to use the same pipeline, but we're going to need to change the name. And we'll use the same runtime as well. Also good to mention, we have model hyperparameters here. We have a single one, epochs, not very exciting. Both the model parameters and the data source are just parameters. You can arbitrarily define them. So if you wanted to throw what type of model it is it clustering or random forest trees? Or if you wanted to throw in more detailed parameters like number of neurons or layers, or what loss function you're going to use, you can define all of that as well in these JSONs, and that way you can parameterize pretty much all the things that you think are important for the model, right? But for now, we're just going to run this as is. So I'll add this new file. And as soon as we add this new file, if we go into OpenShift, we're going to see a pipeline start training or start running. And we have two pipelines. The first pipeline looks at what file has been changed. So we only train or retrain the models which have actually been changed. We don't need to do all of them every time something updates. And the other pipeline is the actual training pipeline. And this one goes through a bunch of steps. I'm going to show them in a slide instead because it's a little bit easier to see. But before we jump into the slide, actually, let's do that first. I'll jump into the slide to show this. So it looks something like this. So we call this the continuous training pipeline. And what it does is it triggers another pipeline, a Kubeflow pipeline it's called. And this is the one that does the actual magic. This does the training. This is the one that defines your model. This is what takes your model parameters and actually runs those. We then get a trained model out of this one. The trained model then gets picked up again by our training pipeline. And it scans it. So we can do security scans and model scans. And it produces a model car from this. This is just a containerized model. So we package the model as a container, which means that it's going to be versioned. It too can be scanned, and it can be cached on nodes and things like that. We then update a GitOps repo. So we have a repo called 9000 model GitOps we're going to look at soon. And whenever this one is essentially plugged directly into Argo CD, and Argo CD just keeps track of the state of our cluster. So if anything changes in this repo, our cluster is going to change. So if we update the model we want to use in the cluster, we're going to update the model we're using. So that's how we deploy our models. We just point to the new model we just created. And it then deploys it to a test environment and creates a pull request to our prod environment. So we get automatic deployment and test that we can evaluate around test zone. And we get a PR, a pull request to prod. So whenever we're happy with the model, whenever we've evaluated it enough, we just accept the pull request. Yes.
Just a quick question, maybe not super relevant for the particular 1,000 models in production, but let's say that when we move to deploying a model, let's imagine that either there's so many models that one cluster to running them is not enough, or maybe we want to deploy the model in a particular location for latency issues. Could it be adapted so that the GitOps thing deploys to, instead of 10 or 50 clusters?
Yeah, there's definitely ways to manage that. Since everything is natively put in Git, you can kind of choose, like it's one source of truth, you can choose where you deploy the models from that. And we have tools like ACM, which can help you sync up to other clusters as well and do cross-cluster work. Finally, we push metadata over to something called a model registry. And this is what gives us the transparency. Like Cansu was talking about, we can now see which pipeline trained this model, what data did we use, where is it running right now. So we get the full lineage of how the model was created, so we can reproduce it exactly, and we can start debugging it if we need.
So that having that continuous training pipeline, you can think of like an orchestrator, because it has the one doing all the steps related, like starting from kicking off the Kubeflow pipeline to basically train the model up to the deployment. It has all these information, like each Kubeflow pipeline that it triggered, and which artifacts that was built, which version that was used to the version of the model, and where it deployed. This orchestrator continuous training pipeline on the top, it collects all this information and now store in the registry. So it becomes our canonical data source, like the source of truth. And if anybody asks a question in a point in time for that specific model, they could get all these information.
Johnny.
Yeah, and so I'm asking question because I seem to remember certain things that was mentioned in the Volvo case. So basically this is more like infrastructure automation. So it's not the continuous training pipeline, is more about generic automation to trigger this entire flow. Could it be, let's say I say, well, we love GitHub Actions. We don't want to use this particular technology. Is that possible?
Yeah. So these are just workflows, and we have implemented them using Tekton and Kubeflow, Argo CD. The exact same principle can be extrapolated to other technology. So the important pieces here are, this central piece. So we go through these steps, and I think in my mind, the most important concept is that we now start treating pipelines as a first-class citizen rather than models themselves. We create pipelines and we manage pipelines, and those pipelines then create our models. That coupled with standard CI/CD workflows for the models and the pipelines makes it very easy for us to have managed these pipelines and have them spit out as many models as we need. Okay, so we talked through this pipeline, but we missed a pretty critical piece here, which is the Kubeflow pipeline. And if you're not familiar with Kubeflow or like what this does, you're still missing how the model is actually being trained.
But before switching to that, Robert, because of the discussion, the pipeline that you kicked off, it actually finished. You could maybe show what changed in the Git repositories or deployed where.
So this finished. So because this finished, as we saw here, we're now going to get a change in our GitOps. So if we go over to the GitOps repo, in here, we're going to see a change. And in test, we now see that the breaks predictor exists. And we don't need to look too closely to this. This essentially just says that the model is deployed or is managed. Well, we're telling Argo CD to deploy the model like this. And we also have our little pull request, which would move this model into production.
We do not directly deploy to production because many of the organizations require some sort of a gated approach before they go to production. They would like to check some maybe end-user testing, like not some automated testing, but maybe checking some stuff or like some sort of an approval process. Pull request, give us that approval. Like someone can look at this and say that, okay, this is running in test at the moment. I can see all the information regarding the evaluations, etc., inside the model registry. And then, okay, we are ready to go to production. And when you merge the pull request, you don't have to go to any cluster or touch any container or anything. When you accept that pull request, the model will automatically roll out to the production. Robin.
You went off mute, but we can't hear you.
Do you hear me now?
Yes.
Now you hear me. I'm curious as how you manage authentication towards GitHub from the pipeline. Is it OAuth or is it a personal token or what is it?
I think we're using a path here. Or
in here, it's a personal token that's saved as a secret inside the cluster, and pipeline is from that secret and use it.
Yeah.
It could be a secret, like a vault or secret management tool to fetch that kind of information as well. But for simplicity, it's just read it from a Kubernetes secret.
Yeah. Thanks.
Welcome.
And to make this a little bit more concrete, we can actually look at the models. So this is OpenShift AI. We're not going to do a full walkthrough of it, but we can now see that in test, We can see our models deployed, and we have the breaks predictor. So it actually worked, which is rare for demos. So, and just for fun, we can also merge this one. Say we have evaluated the model, it works fantastic. We merge in the change, and we'll now start seeing Argo CD. Just to peek behind the hood, it's going to start spinning up a prod deployment. And if we go over to prod, we see it starting here as well. Johnny.
So you did a manual kind of like merge in the pull request, but let's say that where with the model evaluation is pretty much a automated test suite. So we could, in theory, at least, then automatically approve the pull request after the test suite has done the evaluation as well.
Oh yeah. So we just add a manual gate because we heard a lot of requests. Most people don't just let their models into, or enterprises don't just let the model into production automatically. Some do, but this just showcases both options. And it's now been deployed. So we now have it running both in test and in prod. And we can also keep track of this model in the model registry. So if we go in here, we now see that we have the model. We have a version of the model. This maps to the Git version, so we have traceability here as well. We can see
Git commit
what's
ID.
config. Sorry?
Git commit ID.
Exactly. So we can see what config, exactly what's used to produce it. And if we go in here, ignore this text, we copy-pasted this from another enablement. We can see things such as what dataset was used. We'll go over these things a little bit later, but exact pipeline that was used, where it pulled the data from, and what image we used to deploy the model. So from here, you can kind of navigate and get full traceability through the system. All right, so backtracking a little bit. We talked about the orchestrator pipeline, which makes sure that whenever we change a model, we start triggering the training and scan and everything. But we haven't looked at the actual training of the model. For this, we use something called Kubeflow Pipelines. Kubeflow Pipelines is it's a nice way to build pipelines using Python. And because of how we set it up, you can build your Kubeflow pipeline however you wish to build it. In our case, this looks a bit messy, but we essentially fetch the data, validate it, pre-process it, train the model, we convert the model to a specific format, and then we do some evaluation and saving the model. And in these pieces, I mean, this is just Python code. So here is where we would grab our parameters from the config and apply them to whatever training we do. So we can feed in very easily, in our case, just the number of epochs, but you could theoretically feed in an entire model config if you wanted. Okay, that being said, not all training pipelines are the same. So building a single Kubeflow pipeline, which is generic for all the world's models, is both tricky and bothersome and heavy to maintain. So we don't stop with a single training pipeline. Instead, we also have a flow which allows you to deploy new pipelines, either entirely separate pipelines or new pipeline versions of the same pipeline. And how this works is we have our pipeline repo. So this is the training pipeline code. Whenever something changes in there, we will update and deploy all the relevant pipelines. And these then become the pipelines which we used from the orchestrator, like the training pipelines. There are a lot of pipelines going around here, I know. So let me know in case something gets confusing. And by doing this, we can very easily just go into our pipeline repo, and we can add a pipeline like I did here, as through engine pipeline in yesterday. Or we can go into our current pipeline and change things here. Now, if you just change something randomly, we set up so it doesn't automatically do something on any changes. You also need to bump the version. So this way we keep track of what pipeline code correlates to what version. And this version is then what we specify whenever we want to train our model. So this also has the benefit that we can keep training the model with an old pipeline if we want, or we can retrain it on a new pipeline whenever we push out new ones.
Especially if you talk about 1,000 pipeline and you need to make a change or maybe update a library or something in the pipeline side, you wouldn't want to affect 1,000 pipeline at the same time. And we would like to have a more gradual approach and testings with some couple of models, and then make the bigger change later when you're confident with the pipeline. One of the reasons that we are doing everything as code as transparent as possible and bringing all these steps into the pipeline, like such as security, is to build confidence in the process. And when you're confident with your process, when you're confident with your pipeline, that if something is wrong, that the pipeline is going to catch and it's going to stop it to take a faulty model or like a faulty process into the production, you could start actually onboarding up to 1,000 model very quickly. That's why we are following all these good practices that we learned from traditional software, all defining everything as code, doing GitOps, writing pipelines as code, and version the pipelines and tracking those versions in a registry. So this always increase your trust to the process. Yep, that's that Daniel actually.
Yeah, you mentioned in the beginning about rerunning this if you have, for example, new data. So let's assume that you have new data on a monthly basis. What would that be kind of integrate? How would that be integrated into this workflow?
Very good question. So let's talk about when data changes, not just the model. Quick before we do that, just to summarize, we went through a lot of different systems and pipelines. All a user needs to interact with here are these JSON files and these pipeline folders. Any change you do here automatically propagates and updates and deploys your models. So just to give some perspective of what the users would have to deal with, it's not all of these other pipelines and backend stuff we talked about. So let's say our data changes. Now, so what we really only need to do is to retrigger our training pipeline. If we retrigger our training pipeline and point to new data, we're going to retrain the model on the new data. So that makes it very easy. Now, there are a few ways to retrigger the training pipeline on our data. You can retrigger it on just an S3 bucket change, for example, and it just pulls whatever is in the S3 bucket. You can have streaming data coming in, and after X amount of streaming data has been collected, you retrigger and train on the new set of data. In here, we implemented a small piece which uses DVC just to showcase how data versioning also could integrate here. You don't need to use data versioning, but it's quite nice to be able to have the data lineage.
DVC is a quite lightweight data version control tool. There are other tools as well, more capable, but DVC is a good one to start and use it in the demos like this one. So that's why we picked DVC.
So in this case, we're going to base everything in S3 buckets, so object buckets. And we're going to detect when the file changes. Again, you can have a much more sophisticated solution, but this is just showcasing getting new data in. When this happens, we'll get a little event from our S3 bucket, which will kick off an S3 DVC pipeline. The S3 DVC pipeline will grab the models repo with all the JSONs inside it, and it will grab a separate DVC repo, which keeps track of some DVC stuff. And it's then going to run a data versioning. This data versioning essentially just updates our current data, which DVC keeps track of, give it a new version, and then it's going to push this version to our model JSON. So if you remember from in here, we have a little DVC hash. Can anyone guess what happens when we push a new DVC hash to this JSON?
It re-triggers the training pipeline.
Yes, exactly. Yay. So just pushing a new data version to this JSON. We don't only keep track of all the different data versions we train this model on throughout history in Git, but it will also retrain the model automatically for us. So just to showcase that, here is S3. Here I'm going to show on the exhaust data because that's set up. So here we have our data. You can have an arbitrary data sets. You can have different data formats. But I'm just going to update the current data our exhaust model was trained on. And I should have jumped into this folder a little bit earlier. 1 second, I'm just going to find the data on my local. Yes, Robin.
Do you have the DVC versioning in a different repo, or is it in the same repo as the config files?
Very good question. So it's in a different repo to not confuse the config files. So we just have it here, and we have it structured data sets, exhaust data, etc., etc.
Yeah, thanks.
And again, DVC is fairly lightweight here, but you can have something more sophisticated. So I'm just going to drop in a new data. And when I do, hopefully, we'll have a new pipeline. There we go. So we now trigger the DVC pipeline. This is going to do exactly what I said before. So fetch the repos, update the DVC version. So as soon as it's done that, we're going to see both the DVC repo change and the model repo change.
And while this is running, regarding your question, Daniel, this is for like you want to kick off the trigger as soon as you have the data, but you could also just have a scheduled runs for the same setup. Like you could say that my resources are available in the evening at 3 a.m. in the night at 3 a.m. I just want to retrain these models at 3 a.m. You could also set the same thing for that specific time frame. It doesn't have to be instantly. Pipeline has the capability of scheduling.
There's also actually, Olaf, go ahead first.
Yeah, I'm not sure if you want to talk more about this step. That's fine. I have a question that's more another thing. So I'm not sure if you have more to say about this one.
Oh, let me just show the result of this one, and then we can do that one, if that's okay.
Yeah, thank you.
Awesome. So we should now see a update in here.
In the
There we go.
In the exhaust.
Yeah. Oh. In the exhaust. Okay. Right. Okay. Retraction. It finds all the models that uses this data set, and because we copied breaks from exhaustion, it uses the same data set, so both get updated, which means that you can have many models on the same data set, different models, and all get updated as soon as you update your data.
And if you go back to OpenShift Pipelines run now, you'll see that it triggers 3 model training at the same time. So if you go to pipeline runs, so it's capable of running things in parallel as well, like exhaust, engine, brakes. All of them are started retrained at the moment. If they were updated with the main data. Yeah.
Johnny.
So what about like a more like let's say that these models are bigger and we want to like do the training piece on multiple nodes, but also maybe like manage priority and things like that. Is that also something we can? Okay.
So that works really well. So right now we're just running the training as a Python function inside of our pipeline, pretty flat. What you can do is use a training job. So we have a Kubeflow trainer, for example, but you can use Ray or something else. This training job can then be using a technology like Q. This is all are built in OpenShift AI and easy to use, by the way. I can use something like Q to schedule the training pipelines and queue them. And you then schedule them on specific hardware they're allowed to use to get fair share between them. And they're also queued, so they will do one at a time in case you have 9 models all using a single GPU you have. Olaf, going back to your question.
Yeah, sure. So I'm curious about the monitoring part, like when everything is set in production and running, like, there's some sort of ways to monitor, of course, but maybe particularly like data drift, for example, if you have some kind of integration with your pipelines, when drift is detected and so on, how do you handle those situations?
Very good question. So we based this one off of an enablement called AI 500, where we have that, but we didn't include it in this demo. But we can talk about it.
We could show the screenshots as well from the enablement side of things. But
let's do that.
We are able to do that as well. For I heard that Robert, when he was speaking Swedish, he said TrustyAI. So we have a way to monitor data drift and model drift with TrustyAI, and we have a monitoring system built in OpenShift. It comes out of the box. We could monitor those metrics, those drift metrics, and depending on the threshold that you set, it has the ability to trigger a pipeline as well. And after I heard those words in Swedish, I was like, I wish we included that into the demo. But yes, we could do that. So we could trigger pipelines based on alerts for drift and model drift and data drift.
Okay, very cool. Thank you.
This is a screenshot just so you believe that we at least captured it once. So. Okay. I think that was the full base flow. Let me see if I forgot anything. No, I think we're good. Oh, that one's not centered. Some possible additions. So we already talked about 2 of them. So monitoring and trigger and monitoring and scheduling training jobs instead. So we get better use of resources. Then, of course, running 1,000 models is going to be difficult if you just run it on a single small cluster. So you need to take into account how to scale the infra as well. We already talked a bit about that you can do multiple clusters, and since everything is based in Git, there are techniques to do that, and there's technologies like the advanced cluster ACS, it's called, yes, to help you with that. And the final thing we haven't talked much about is batch processing. So everything we've done now is to get a model up and serving. Of course, you then need to use that model, so you need to send data to it and get responses. You could use these exact flows, but instead just use the model to do batch prediction instead. So you don't spin up and serve a model. Instead, just use the model inside of the pipeline, predict 1,000, 100,000 samples, whatever you want, and then get the results dumped into a database.
The beauty of making things composable and like small like Lego bricks with all those diagrams and these boxes, that means that you could actually turn these off and on, like enable them and disable them and fit them into your use case, basically.
In this case, it would just be a different KFP pipeline, and it would be good to go with the batch processing. Robin.
Yeah, if you're using batch processing, how do you handle monitoring and drift detection and stuff like that?
Very good question. So I would have evaluation steps inside of the pipeline that detects the drift on just the batch data you process, and grab any metrics you're interested in. So it'll be exactly the same. You would just get them in the pipeline rather than online from a served model.
Yeah, thanks.
There was a mention on training, and maybe just for context, there is a plan that through the project, and I know Kim is involved, and Andreas Bergqvist is also on the call that can answer more questions. But there's a plan to actually, I hope, bring both Cansu and Robert to Stockholm. I don't know if it's going to be you guys, but people from us to actually do this training that Robert showed the screenshot from the model monitoring piece. It's going to run in Stockholm at some point during the fall. And if you're interested, make sure that you mention this to Kim or Andreas that is on the call. It's being funded by Vinnova to Reddit, and we're kind of like investing back into the project and offering this training to the members of the project.
Awesome. Thank you very much for bringing that up. Okay, so is this your part again, Cansu?
Yeah, it's just a summary of 3 key points that we showed that with this kind of an approach, having like an orchestrated pipeline, making things as parameterized as possible and able to track the changes along the process and bring in security early on, including monitoring observability piece of this will help you to scale up to 1,000 or 9,000 models and make the whole system more reliable and secure and basically that's what we wanted to run at the show. And actually how we can go from one model, how can we build this kind of a process, basically this kind of a system is, as just trying to mention that we started this enablement with just one model, and that's how you would do in your own organization as well. Like you pick one use case, you build all these automations around that one use case, but a use case that would be pretty similar to the other upcoming use cases. So you start with one, prove that the automation works, prove that what kind of automation, like the parameterization, etc. you need, generalize the flow on top of that one, and then actually you scale from that, maybe domain by domain and group by group in the next. If you go to next one, Robert. Yeah, it's basically usually what we see in the customers is like how to scale, and it's we find this to talk about easy because that's exactly what we've been doing in DevOps space in the traditional software. How when the containers started to become a thing, how am I going to containerize all these applications, break down and put into production? This comes with the same logic. You prove the point with one, you generalize the flow, and you scale with iterations, and at the end you'll have 1,000, 9,000 models in production. So just to give you an idea of where would you start if you were to do that.
So sorry to put you on the spot, Cansu. So you say like for the demo, to put you on the spot. So have you done something similar with anyone? Like, do you have a public reference if someone wants to maybe take a look at some form of I don't know? Have we done something similar? Is maybe what I'm asking.
We have. Oh, sorry, that was for you, Cansu. But we have one which is private but public. Yeah. But maybe public soon.
It is on the way to public. Yeah.
So I'm not going to say the name, but they're doing some. I was about to, but they're doing something very similar to what we showed here. They structure the repo slightly differently, but the principles are all the same. They create pipelines, they trigger the pipelines, and pipelines create multiple models. So keep your eyes out. We're happy to link it to this group as soon as it's available. I think they're chatting with marketing right now on a blog to create. We're also trying to get them to Summit. We'll see if we manage with that.
Yeah. But we did this a lot in the traditional software side of things, basically. This kind of building a platform and lowering the entry barrier and increasingly onboard many applications for workloads like Java, Node.js, etc. it's different, of course, in machine learning, but we have good experience from that we could easily channel and bring it here.